Hello, Stats 300, and this is Professor Gonzalez. I'd like to do some problems out of ALEKS for you today, and these problems are going to be out of ALEKS under the section of assignments, which are kind of symbolized by this green box. And this is homework assignment HW 7.2. This first question, number 1, talks about converting a raw value, raw score, into a z-score. So before I do that, I kind of want to give you a little background information on that, maybe kind of hit that again. What I'm going to do is I'm going to draw a picture down here, and then I'm going to erase it because we'll need the space for the next problem. But I've got, so this first problem talks about this normal distribution. A normal distribution has a mean of 58, a standard deviation of 20, and we're trying to interpret the z-score for a raw score of 69. Well, let's hold off on that. Let's just talk about the situation where a mean is 58. So, when they're talking about a raw score or data, let's just call it raw data. This is in a normal distribution, so it has this normal curve, and the mean is going to be right here at its peak point because it's a normal distribution. And this particular mean with the raw data is going to be 58, has a standard deviation of 20. Okay, this basically means if you go up 20 points on this, which would get us to 78? Okay, that's one standard deviation above the mean of 58. Now, if we, let's see here, let's go to green. If we change this from raw data to a standard normal curve, standard normal curve, its mean is always 0. So, in fact, if we used our formula, z equals x minus the mean over standard deviation, if we use 58 minus 58, it's going to put a 0 in the numerator rather, so we'd get 0. But let's go ahead and calculate this raw value and see what that would be. Well, let's see, z equals, remember it's a raw value of 78 minus the mean of 58 over standard deviation, which is 20. Well, 78 minus 58, well, that gives us 20. And 20 divided by 20 would give us a z-score of 1. So 78 in the raw data converts to 1 on the standard normal, or a z-score of 1. So what I'm trying to get to is this little bit of this first question might be a little bit confusing. And what they're getting at is that they're basically saying we would say 78 is one standard deviation above the mean. So these z-scores, it's kind of like basically reconfiguring the scale. So whenever you have a z-score of 1, that is one standard deviation regardless of what the data is, right? If the in this particular data, one standard deviation is 20, right? So one standard deviation is 20 points on the raw data. Well, what is a half? What if z equals 0.5? A half, z equals half. Well, in the raw data, that half would be how many? What's half of 20? That would be 10 points. Let's do that. So if we took a look, oh, that's the wrong thing. Jeez. Oh, and there goes that hole. Okay, it's all falling apart now. I used the wrong, let me see if I can redraw that. Nope. Let me try again. Okay, so if we had a z-score that was a half, right, 0.5, what would that translate to with the raw data? Well, with the raw data, that is half of a standard deviation. If a standard deviation is 20, half of a standard deviation is 10. So a z-score of 0.5 is going to line up with 68. Okay. Now you see the problem we're going to do is asking us to convert a raw score of 69. Well, we found out that 68 is about exactly a half standard deviation. So when we actually get to it, number one, it's going to be a little more than 0.5. Okay, let's do it. So let's get rid of all this stuff as fast as I can. Not as fast as I thought it was going to be. Let me see, do I have this thing? Yeah, it's supposed to go fast with this eraser. It's supposed to just touch it and it goes away. All right, so let's do the problem now that we hopefully have a better understanding of where we're going with this thing. So essentially, we need to take this raw score, use the formula z equals raw value minus mu divided by the standard deviation. So let's do it. Z equals raw value of 69 minus standard deviation of, what was it, 58? Divided by the 69 minus the mu, the mean of 58, divided by the standard deviation of 20. And what do we have? 69 minus 58 is 11. And 11 divided by 20 gives us 0.55. Hey, that's, like I said, it's a little more than half. Okay, so here's where maybe some people are having some questions. Fill in the blank. Okay, let's see. The z-score for a raw value of 69 is, okay, so the z-score is 0.55. So 69 is 0.55 standard deviations, and this is to the right of 0, right? So it's above the mean. Okay, so hopefully that helped out. Once again, we know it's above the mean because with our standard normal curve, always the mean is 0. And if you're at 0.55 on the positive side, that's definitely above. And you could also get to that idea of it being above because remember the raw score was 69 and that's definitely above the mean of 58. Okay, so you kind of get there in a couple different ways. Let's get rid of that and start looking at our next problem. So our next problem here, and change to black. Our next problem here says a normal population has a mean of 7 and a standard deviation of 5. Okay, what proportion of the population is less than 19? So once again, let's go, with this idea of raw data. The raw, and in this part, you don't have to do this every single time, but just kind of getting the idea, I think. The raw data says that the mean is right here at 7. I think it's good to draw the picture, especially when you're first learning this. Raw data is 7. Standard deviation is 5. Okay. What proportion of the population is less than 19? Well, 19 is definitely to the right of 7, so I'm going to put it way over here. What proportion of the population is less than, this pen is not working, less than 19? Well, less than 19 is going to be, the area under the curve to the left of 19 is going to look something like that, right? Well, we don't have a way of calculating the area under this curve unless we use a z-table. And use the z-table, we've got to convert this raw data into a standard normal using the z-score, using a z-score to do that. So let's go ahead and do this again. It's standard normal curve now. There's, of course, standard normal curve. That is going to be a 0 there. And we need to figure out what this z-score is going to be right here. Now, we can do that. Let's work it over here. This is going to be, to get the z-score equals my raw score of 19 minus the mean, which is 7, divided by the standard deviation, which is 5. Okay, this gives me 19 minus 7 is 12. And 12 divided by 5 gives me a z-score of 2.4. So this is 2.4. Okay, so I'm looking for the value that is less than 19. That is to the left of 19, but its raw score 19 translates to a z-score of 2.4. And I think I'm going to use a red pen so you can see my work on the z-table chart. I'm looking for that red area to the left of 2.4. Okay, I need to go to that the z-table. So I scoot down here to the z-table, and what was I already forgot what I'm doing. 2.4 is the z-score I'm looking for. 2.4, this is the positive side. You could tell it's the positive side because that z is to the right of 0. 2.4, and there's 2.4 right there, and 2.4 is 0, so it is literally going to be right there, which is 0.9918. 0.9918. So I come back up here, and I can say the answer is 0.9918. And that is the answer to question A. Okay, let's see if we can squeeze question B in here. Some reason, okay, there we go. Okay, so question B says, what is the probability that a randomly chosen value will be greater than 4? We're still talking, round your answers to 4 decimal places. Okay, good. Well, that's the exact value that my z-table came in, is 4 decimal places, so I couldn't round any more than that. That's all was given to me. Anyhow, what's the probability that a randomly chosen value will be greater than 4? So once again, I'm going to be tight on space. Let's see if I can do this. You know, that raw distribution, if we're just getting a picture of that. Once again, our original problem says the mean was 7. Raw score 4, well, 4 is less than 7, so that's to the left. And they want to know what's the probability that a randomly chosen value greater than 4. Greater than 4 is definitely to the right of 4. So we want to find the area under that normal distribution to the right. And we know when we go to the right, it's a little more challenging because because our z-score will give us the area to the left. So we got to do a little more work. Let's redraw this real quick. And we're going to draw the standard normal curve. So there's a 0 there. We need to calculate what is that in terms of z-score. So let's do that over here. Z equals a raw score of 4 minus a mean of 7 divided by the standard deviation, which is 5. 4 minus 7 is negative 3 divided by 5, and this gives us a z-score of negative 0.6. So this raw value 4 becomes a z-score. I'm a little bit far over anyways, but yeah, let me redo that. This part's not that important. It's just, trying to draw a picture, but I'd like to be a little more accurate. I think it's going to be more like right here. It's not that important. This is going to be, what did I say? Negative 0.6. And it says we want it to be, we're looking for the value to the right because it's greater than. So we're looking at that. Okay, we need to go to our table. Let's use some green for this one. So we need to go to the negative z table, and we're looking at negative 0.6. Let's go down there, negative 0.6, that's positive. Negative 0.6, there it is, negative 0.6, and there isn't any more to it. So, you're going to use the 0, 0 because it's negative 0.60, right? Negative 0.6 is right there. So this is 0.2743. 0.2743. So often students will take that number and think that's the answer, but you just found the area to the left because that's what z tables give you, is area to the left for a z-score of negative 0.6. So if you use that, you're going to be upset because you're going to punch it in. You think you did everything right. You just did one little thing wrong, right? You forgot to subtract out 0.2743. From what? Well, the total area under that curve is 1. So if you take 1 minus that green stuff, you're left with the shaded value to the right, and that's what we're looking for. So 1 minus 0.2743 gives us 0.7257. And that is the answer for part B. Okay. Let's see, now what are we going to do? Let's go ahead and take a look at question number 3 down here. And this one, at least we have a lot of space to work with. That's great. And we've got 2 parts. Okay, so a standard normal population has a mean of 30 and a standard deviation of 6. What proportion of the population is between 16 and 26? Now the problem here is, once again, is that now we're going for an interval, so we've got to do even a little bit more work. And remember from 7.1, we did this already, but now it's, they're asking it, instead of just giving you a picture, they're asking you to draw the picture, and so it's asking a little more from you. So let's go ahead and draw the picture. Let's see, what does that picture look like? This is part A. Once again, just to kind of get that full visual, and then we're just, let's see. Okay, so our normal population has a mean of 30. And we're trying to figure out the proportion of population between 16 and 26. Well, 26 is not even up the mean, so it's going to be, something like 16 maybe here. And 26 is getting close to 30, which is hard to draw when I'm trying to conserve space, but let's go like that, 26 right there. Between, so we are going to want this value, the shaded region band in between is what we're looking for. Okay, of course, these are raw scores, and we have a z-table that gives us values for z-scores. So let's go ahead and see if we can do this again with z. So there's my standard normal, getting a little sloppy there. Of course, now it's a 0. We look these values up. Do we need to do that again on our table? Let's do it one more time, looking up in the next one. I think I'll just tell them to you. Once again, we need to look up these values. So let's let me just use some color. Well, let's see. Actually, let me prep this because I've got a table that's got things on it. So let me clean this up, clean house a little bit. Okay, let's go back here. And let's use some green. So, before I do that, let's figure out what these values are in terms of z values, z-scores, right? So how do we do this? We take z equals a raw score of 16 minus my mean of 30, right? And 16 minus 30, and it's over, what was standard deviation? 6. So 16 minus 30 gives me negative 14 over 6. So therefore, this z-score, negative 14 over 6, is approximately, we do have to do some rounding, negative 2.33. And our second z-score, which is found from, 26? So 26 raw score minus mu of 30 over standard deviation of 6. This is going to, 26 minus 30 is negative 4 over 6. Another approximation, round it to the nearest hundredth, so negative 0.67. You know these values are going to be negative because they're to the left of 0. And of course, the further you go to the left, right, the more, it gets further negative. So we've got this, this one is negative 2.33, while this one is negative 0.67. And we want to find the area in this band right between those two values. That's what we're looking for. Something like that. Okay, so we need to first look up negative 2.33, and when we do that, that's going to give us this green area. Not what we really want in final, but we do need that to get to where we're going. So we look at negative 2.33. Let's look that up. Negative 2.33, negative 2.3 and 3. So come on down here, negative 2.33. Jeez. So that area is 0.0099. 0.0099. Okay, well, I'm running out of space. So if we put in or look up the value of negative 0.67, that's going to give us the area from here. I have to erase that because it's kind of getting in my way. That's going to give me the area from here all the way down, and we're going to have to do some subtraction to actually figure out the shaded part. We look up a negative 0.67. Let me do one more of those. Negative 0.67, negative 0.6, there it is. 7, there it is. So negative 0.67 is 0.2514. 0.2514. To get the resulting shaded region, we take the larger area, which is 0.2514. We subtract out the smaller area, which is green, which was 0.0099, and that will give us the resulting band that we're looking for. What is that going to be? What do you say? 0.2514 minus 0.0099, which is 0.2415. And that is the answer. All right. Let's see if we can do part B. And then we're done with 7.2, at least the assignment part of it. And so we take a look at this one. This one is, well, let me get rid of some of this right here so we can see what's going on. What is the probability that a randomly chosen value will be between 25 and 35? Okay. So how about if we, on this one, how about if we just go right to the z-scores? So let me find the z-score of 25, which is going to be, the raw score is 25 minus the mean, which is 30, divided by the standard deviation, which is 6. 25 minus 30 gives me a negative 5, divided by 6 is approximately, oops, forgot my negative, approximately negative 0.83. Okay, and then we need the z-score for 35. So now z raw score is 35 minus a mu or mean of 30 divided by standard deviation. Now, you see 35 is larger than 30. 35 is larger than 30. This is going to give us a positive z-score, and you can see that happen here. 35 minus 30 is 5, and 5 divided by 6 gives us approximately the positive value of 0.83. We're, of course, rounding on that one. Now, I didn't write the raw data as a normal distribution, but I'm trying to save a little space on this one, and you'll see some redundancy with that. So now I'm just going to write the standard normal curve, which always has the mean at 0, and you can see we have a a value over here of negative 0.83 and positive 0.83 or 83 hundredths. And we're trying to find the area between those two values. And so we can do that. And, you know, there's different procedures of finding the shade region, but we're just going to stick with the same way that we've been doing it. And that's just going to be, well, let's figure out, well, what is this area? And that can be figured out by looking at a table using a negative 0.83, and that gives us an area of 0.2033. And using the same pattern we did before, figuring out the area from here to here. Can I fit that in? Using a z-score of positive 0.83, I get a pretty large area of 0.7967. Of course, now we take the larger red area, 0.7967, subtract it from the smaller area, which was 0.2033, and that is going to give us the resulting band right there, and that is, or the shaded region in between .083 and negative 0.83 and positive 0.83. Anyhow, the resulting area is 0.5934. Didn't mean to extend that one out so long, but there it is. And so that is our answer, and I hope this helped a lot. Everybody take care out there, and I'll get back with you with another one of these homework assignments. I also actually, the next one I think I want to give you some of the problems out of the interactive ALEKS questions. Some of those are, there's not a lot of them, but there's in the form of a word problem, so I want to do some of those as well. Okay, everybody take care, and signing off. Bye.